Hi friends, welcome back to my physics channel once again. In our series of moving charges chapter, the second year physics, very important. We'll discuss today what is the magnetic force acting on a conductor. You can see I am showing with a big size and the big size conductor with a zoom size చూపిస్తున్నాను చూడండి. This is the conductor carrying current. అది ఎలా ఉంది conductor? The axis is making an angle theta with the magnetic field direction. చూడండి ఇదంతా magnetic field ఇది. This is magnetic field induction. The axis, horizontal axis is making an angle theta with the magnetic field induction. ఇలాంటి సందర్భంలో how to calculate the magnetic force, okay, acting on this conductor. So magnetic force acting on this conductor calculate చేయాలంటే already we derived in previous videos force acting on moving charges. ఏంటది? QVB sin theta. This is already derived from, okay, xy plane లో charge move అవుతున్నప్పుడు v velocity తో we have conducted by using the cross product by using the curl rule, okay. So అది కట్ట already. So by taking that force we can derive this equation, magnetic force on a current carrying conductor with the axis making an angle theta with the magnetic field. So equation తీసుకుంటే see here magnetic force is equal to q v. V means here what? Velocity. ఇక్కడ velocity అంటే ఏంటి? Drift velocity. See here v means nothing but vd, that is drift velocity of the electron, please. Drift velocity already మనకు తెలుసు కదా, around 10 to the power of -3 to 10 to the power of -4 meters per second. That is the drift velocity, very slowly, of the electrons. So drift velocity. B magnetic field, sin theta is the angle. Now drift velocity అంటే ఏంటి? Electrons are moving in opposite direction of the charge. Okay na? Suppose this is the charge, current direction. Electrons will be moving in this direction, opposite direction. So move అవుతున్నప్పుడు ఏమో displacement ఉంటుంది. So displacement is equal to velocity into time. Displacement of the electrons is equal to velocity into time. Velocity is drift velocity. So therefore drift velocity into time is equal to this thing, displacement. So ఇందులోంచి what is L by T? L by T, displacement time is equal to velocity. So ఈ velocity ప్లేస్లో పెట్టారు, ఓకేనా. సో velocity ప్లేస్లో పెడితే ఏమవుతుంది? L by T into B ప్లేస్లో magnetic field into sin theta. But we already know what is charge flowing in the conductor per second. Q is given by I into T. Q is given by I into T, strength of current into time. So into L, I mean what? L by T అంటే V drift velocity ఎంత అయింది? L by T into L by T into B into sin theta. T gets cancelled. ఏం మిగిలింది ఫైనల్ మనకి? magnetic force is equal to I L B sin theta వచ్చిందా? దీన్ని బిల్ సైన్ థీటా కూడా అంటారు. మ్యాగ్నెటిక్ ఫోర్స్ యాక్టింగ్ అనే కరెంట్ క్యారింగ్ కండక్టర్ ప్లేస్డ్ విత్ అన్ యాంగిల్ థీటా విత్ ద మ్యాగ్నెటిక్ ఫీల్డ్ ఇండక్షన్. I strength of the current in amperes, L is the length of the conductor, B is magnetic field in Webers per meter square or Tesla or Newton per ampere meter, and theta is the angle between the magnetic field induction and the axis. Maximum ఎప్పుడు ఉంటుంది? sin 90 maximum కాబట్టి then F is equal to ILB newtons. Minimum ఎప్పుడు ఉంటుంది? when the angle is 0, sin 0 కాబట్టి. So like this we can find out the magnetic force for a current carrying conductor with the axis placing at an angle theta with the magnetic field. Okay na? Again we'll meet with the another video.